This is lecture 4 of week 4 in CS 1030. And the topic of this piece is abstraction using functions. And this is going to get into one of the absolutely most critical and important ideas in all of computer programming. This is absolutely crucial that you understand this material. So we'll spend some time on it. So let's talk about what abstraction is. Abstraction means simplifying complex ideas or complex processes by getting rid of unnecessary details. And so if you're implementing an algorithm and there's some sub part of the algorithm that you've already solved, and what do I mean by that? Well, what I mean is that we've seen that in the insertion sort, we needed an algorithm for putting something in a proper place in a list that's already sorted, for adding a new item to the list and keeping it sorted. For the selection sort, we needed an algorithm for finding the smallest item in an unsorted list. So those are sub-problems of larger problems. And once we've solved that sub-problem, we don't want to think about it again, really. We just want to kind of use the solution that we've already developed. So that's what abstraction using functions is about. It's about taking a piece of functionality and sort of bottling it up so we can just use it, so we can forget about the details about how it worked. And this is, again, possibly the single most powerful idea in all of computer programming for making things actually, for actually being able to solve complicated problems using our sort of, our kind of forgetful, lossy sort of brains that we happen to have been given here. So the idea is that, taken as a whole, computers are just gigantically, enormously complicated. There is just a lot going on a computer. And so one of the things I do in my research part of my life is I think about operating systems. And, so I sort of know how they work all the way down to the hardware. And there is, just trust me, there's an enormous amount going on there. And mostly we just don't care. We just want it to do its job. And that's, this is abstracting away the function of the operating system. So just as an example of that, if you move the mouse pointer, so here I'll just move the mouse pointer on my Mac. So when I move the mouse pointer, it's probably tens of thousands of lines of code that execute just to make the screen reflect the moving mouse pointer. And of course, to record that using Zoom and then ship it all to YouTube, there's millions and millions of more lines of code. And it's too much for any human to think about. Nobody could really understand all of the stuff that's going on all at once. Our brains just kind of aren't built for this. But what we can understand is that there's some part of the computer that is, asking the mouse where it moved to, and then moving the picture that shows a little mouse pointer on the screen to somewhere new. So that's something we can understand. If we abstract away all the details of, communicating with USB mice through a USB hub or whatever, and then the details of talking to a complicated graphics card that, it's smart enough to play the latest games, if we ignore all that stuff, it's easy. If we don't ignore it, it's impossible. And so that is basically the power of abstracting code using functions. And you basically can't be a programmer without getting on top of this idea. So we're going to spend a fair amount of time on it. So let's talk about the abstract idea of a selection sort. So remember, we talked about selection and then insertion sorts. So while items remain in the unsorted list, find the smallest item in the unsorted list, put that at the end of the sorted list, and then remove that item from the unsorted list. So the question is, what have we abstracted away here? Well, we've abstracted away a lot. There's 3 jobs here, none of which is super trivial on its own, but we've sort of encapsulated we've encapsulated them at a high level. So let's sort of look at an example here. So find the smallest item in unsorted. So if we want to, when we've abstracted that away, we don't care how it works. But let's say we haven't abstracted it away yet. We need to actually make that happen. So what's the algorithm we want to use for finding the smallest item of a list? That's one we talked about already. It's sequential scan. So a sequential search. So a sequential search is an algorithm that is able to find the smallest item in a list. We can write scratch code for it. In fact, we saw that in a previous lecture. And then once we have that scratch code, we can actually just sort of use it in an abstract form. We can just kind of make a name for it, like find smallest item, and then we can just refer to that and use it without caring about how it works. And so I'm not going to do it in this lecture segment, but in the next lecture section, the next lecture for this week, I'll show you how to actually do this in Scratch, and it's pretty cool. Thank you.